Test? OK, that's better. Hi, yes. Hi, everyone. Thanks for taking some time. Oh, that's a big crowd. OK. Yeah, my name is Antonio. I'm a software engineer at KILT Protocol, and I'd like to present the Decentralized Identity Provider, or DIP. So before explaining what the DIP is, I'd like to trace a very brief history of how identity management has changed over the years. So in the 90s, a user would typically set up different accounts for each service that they wanted to use. This means 3 different websites, potentially 3 different email addresses, and 3 different passwords, or the same one everywhere. And the natural development 20 years later, in 2010, was to improve the user experience by centralizing the identity management. So this apparently represented a win-win situation for both users and services, because users would have only one identity to take care of, while the services would have less liabilities and less things to protect because they delegate identity management to a third party. Several iterations and names have been given to different delegation protocols, but the most recent one for identity management is called OAuth and OpenID Connect. The first deals with user authorization, and the OpenID deals with user authentication, which has been also the main inspiration for the DIP protocol. So in very simple terms, the OpenID protocol is composed of 3 different parties. We have the end user in the bottom, the identity provider, such as Google on the left, and the relying party, for instance, the Discord or Zoom on the right. So the way it works is very simple. First, the user obtains an access token or an identity token from the identity provider, which is, of course, digitally signed. Then they use the token to access a service. Of course, the relying party have to trust the information provided by Google, in this case, because it's sensitive information, so there is no way for an app like Zoom to verify themselves whether the information is true or not, so they have to trust that Google gives them the right information. This definitely does bring convenience on one side, but we've also seen that it gives huge powers to these identity providers, both in terms of the control of the information that is shared and the amount of data they have now available, so they can get information of which services the user uses at what time. In Web3, things go a little bit better. Wallet-based logins definitely represent a more decentralized approach to solving basically the same usability issue. But nevertheless, the main limitation is that at the end of the day, a user is logged in with an address. So anything else they want to share with a particular platform must be compiled per platform, for instance, a profile picture. And now also users are using a wallet address to represent their identity, which we think it's not necessary. It's like logging into a website using your entire bank transaction history. And if we go even deeper inside the Polkadot ecosystem and we look at blockchain runtimes, we see that the way of handling and interpreting user identities is even less clear. Each chain typically deploys their own version of identity, like the identity system, and cross-chain identity is even hard to even conceive because there is no uniform way of doing it yet. So the one identity, one application, or one blockchain brings us back to the 90s, where you have one account to each blockchain, while the service is now a blockchain. And the idea, the limitations stay the same. So this means that usually a blockchain deploys the identity palette, and the main challenge for a user is to update information on all the different chains and keep it in sync. And we think that accounts are meant to only pay for fees and not really to provide any sort of identity information. So the identity should live on a different layer, which is different than the layer of blockchain accounts. This illustration here is on purpose similar to the one about OpenID, because we are basically trying to bring those concepts into the Web3 world, and we are doing that with DIP, or the Decentralized Identity Provider. The naming, of course, is not original, but it gives away what it does. It's basically a protocol to enable users to have their identities on a single place to manage, but still giving them the chance to use them in multiple different locations without sacrificing usability and decentralization. We wanted to retain the same naming as in the OpenID protocol. So we have the identity providers, such as KILT on one side, and the relying parties, such as other blockchains. Frequency, Zeitgeist, and Astra are just some examples on the other side. So the flow is very similar to the OpenID flow. The user first goes to the identity provider chain, such as KILT. If they don't have a KILT identity, they create one, they set up one. Then they bridge the identity information onto the receiver chain. What information is bridged is up to the definition of the identity provider, and I will go a little bit more into details of what that means in a while. In the current version 1, or in the version 1 that we're working on, this will happen via XCM. And the main difference between the OpenID and the DIP protocol is that, as I said before, OpenID requires the relying party to trust the information they get from the identity provider, while in the case of DIP, everything is verifiable. Hence, there is a truth relationship rather than a trust relationship between the identity provider and the relying party. So once an identity has been bridged to destination, the user can just use it without having to interact with the provider anymore, as you see here. And because it's a protocol, of course, we welcome community members and other projects to collaborate and work together. And so we see also other identity providers, meaning other blockchain that do something with identity, for instance, our colleagues at LeetEntry, to basically implement their own version of identity and basically finding their own customers where these identities can be used. And the process would be exactly the same. What changes is just what information is sent between the provider and the relying party chain. Yeah, so that's what I was saying. And yeah, after that, a LeetEntry user can just use their bridged identity onto whatever chain accepts LeetEntry identities. So, of course, from the point of view of the relying party, a chain can choose to integrate more than a single identity provider. And as is the case of an app that accepts multiple different login methods, for instance, Facebook, Google, Apple, a blockchain that accepts multiple different identity providers get access to the information graph that each of the providers have built over time, basically for free, by just supporting a new provider in their runtime. Now, on a somewhat high level, this is how DIP is structured, will be structured. The main components are two pallets, one to be deployed on the provider chain and one to be deployed on the receiver chain, and the two pallets interact with each other with a HRMP channel. And for a user to bridge their identity, they would go on the provider chain, they dispatch an extrinsic, they call a transaction, you name it. They specify to which location they want to bridge their identity to. Then the pallet takes care of generating all the XCM message, all the logic, and just dispatches the message to whatever destination the user has chosen. And then once the identity has been bridged, the user goes on the target chain, on the relying party, and they just start using the identity right away, basically following whatever fee model and consensus model the receiving blockchain follows. The pallet will just take care of validating any identity proof that the user provides. Of course, the format is depending on the provider that the user is using. And if all the checks pass, then the call will be dispatched with the new origin information that the pallet has created. And of course, it's available to the runtime to consume. So yeah, because the identity has been bridged, there is no need to do the whole process over and over again every time the user wants to do something, so they can call a second time. Whatever call requires the specific identity to be used, and maybe even a third time. Of course, the consumer can then specify logic by which, for instance, they require users to re-bridge their identity every, 7 or 10 days if they want to get rid of some outdated information, for instance. But that's agnostic to the protocol, that's up to the consumer. So what are the advantages of using DIP? Oops. Yeah, so the identities become portable. We move again away from the one identity, one application, but rather into one identity main applications. The chains, other than identity providers, can focus on what they can do best, and they can delegate identity management to the chains that do that for a living, for instance, KILT. And yeah, most importantly, users have that identity in a single place, for instance, the KILT chain, and they have a single source of truth where they can manage everything and then just bridge it to other chains. Yeah, and this is what I mentioned also before. We think that identities have to be decoupled from accounts, and this is exactly what DIP enables. The DID, or rather the identifier of the user, doesn't necessarily have to be the account that acts on other blockchain, and I will explain that a bit in a bit detail when I talk about the KILT way of implementing the protocol. And yeah, this is the mantra that has been following us for a few years now. Of course, it's less trust, more truth. So yeah, moving on to KILT as an identity provider. As I said, it's a protocol, so anyone is free to implement either part of the protocol. KILT will implement the provider side. and it lets KILT users interact with other blockchains that accept KILT as a potential identity source. And why would a chain use KILT is because what KILT does aims to be standard compliant with the latest development in the decentralized identity space. Talking specifically about decentralized identifiers and verifiable credentials, plenty of resources online. For time reasons, I'm not going to go into detail what those are. But yeah, basically, a user has a Web3 name, could have a Web3 name which is a unique user-friendly identifier for the DID, could collect credentials from different testers, for instance, Deloitte, as the talk this morning showed, and can also link multiple different accounts, either Polkadot or EVM-based, and we plan to add new accounts in the future as we gather more needs and more feedback from projects that want to use KILT as their identity provider. And now you can see that if a user has a KILT identity, they can not only use it in dApps, for instance, Polkaverse, Polkassembly, or Subsquare, but they can now bring it down to the blockchain level and attach identity information to the transaction directly, if necessary. They're not required to. For instance, some use cases that would greatly benefit from this would be governance participation or KYC like operations that require a KYC level at the blockchain layer, or NFT-gated operations, for instance, because KILT user can link EVM accounts and they can then prove that they own these accounts on whatever chain they're operating. So yeah, as I said, KILT is based on standards that have been battle-tested, developed, and tested by a way larger community of identity experts. Yeah, it's kind of easy to integrate the KILT stack, and people can do it in dApp already now, based on DID standards like the SIOP v2. Again, for time reasons, I'm not going to go into detail. But also soon with DIP in blockchain runtimes directly, creating a uniform top-to-bottom stack of tightly integrated KILT identities. Yeah. That's what I said before. Yeah, now I think I have some time for some demo. Let's see if that works. I need to bring this over here. And this is always tricky, but let's see if it works. OK, here. Yeah, so for the demo, we have deployed a test environment, so a local relay chain with 2 parachains. One is a KILT demo version of, it's basically the Spinet runtime with the addition of the new DIP palette, the identity provider palette. And then we have a very simple relying party blockchain, which has just a very bare minimum number of pallets and only 2 additional pallets. One is the DIP consumer or DIP relying party, and the posted pallet, which this dApp is built on. So what this dApp does is allows, again, for demo reasons, allows anyone that has a KILT Web3 name to post on-chain messages for other people to like, comment. That's it. So yeah, what I can do is I can show that I have my Sporan wallet. This is also a kind of a fork of the official Sporan, in which I have 2 identities. One has a DID and already a Web3 name, and another one has only a DID, no Web3 name. So the first thing I'm going to do is I'm going to claim a new Web3 name. I'm going to do X3 because I already own X2. They're unique, so you can't claim the same Web3 name twice. Oops. Yeah, the identity has been created. We can see the event generated on the chain. Yeah, so it's been claimed. Sporan waits for finalization, so there is a bit of lag in the process. But we should be done in a few seconds. Yes, OK. So now I already had a DID, and I have claimed a Web3 name. I linked to my DID. Now, if I want to start using this app, I have to first breach the identity on the target blockchain. This app has no backend whatsoever. It's entirely like living in the web page and connected just to the receiver, to the demo blockchain, right? So I'm going to bridge my identity from KILT. This is so uncomfortable. Yeah, I'm sharing my new Web3 name. I'm going to assign it. And here I can see that I'm committing the identity from the KILT chain to the receiver chain. And now we can see that the message is, OK, so the XCM message has been dispatched, and it will be received at some point on the receiver chain. Yes, OK, so we have now breached the identity. What I can do now, I can post something. Oops. Yes, and I post. Now Sporum pops up and say, yeah, you're trying to post something. This is the Genesis hash of the target chain because we can bridge identity onto multiple different chains, and for security reason, we bind daily signatures to specifically for one blockchain. And yeah, I'm going to sign this operation. This happens, what Sporum does is simply generating a deity signature, and because we have identities and blockchain accounts separated from each other, we can actually let the demo dApp have a mnemonic and pay for all the fees. The user just signs the operation, committing to what I want to do. And which one is it now? Oh, no. Yeah, this one here. So you can see now that the Web3 name NTNX3 has left a post. What I can do now, I can switch my identity. I can reload the page first. This is a demo page. I can bridge my other identity where I have my NTNX2 Web3 name. So I'm going to share this one. Yeah, and I'm going to do basically the same process. Let's see if this works. This is the old one, I think. Yes. Yes. So another XCM. This is the same process. It takes around 30 seconds to be completed. But now I'm bridging my other identity on the same blockchain because I want to use, for some reason, 2 different accounts. And now, yes, it's been bridged. This is the very long DID. That's why I claimed a very user-friendly Web3 name. And I can now basically reply to my own comment. And then Sporum pops up, asks me to sign the same thing, just the comment operation here. Let me save this. Yes, and now we can see. So the event is there. Just need to wait for the dApp to take the new information in. Yes, OK. So now I have used my other Web3 name to comment on the same post. This is just for demo purposes. But yes. But yeah, so everything happens entirely blockchain-based. There's no login into the website. There's no off-chain interaction there. I think, yeah, that's what I wanted to show. Sorry. How do I? There we go. Yes. So yeah, that was it. We have an OpenGov proposal on Polkadot to fund work that has already started November last year. We have few low-hanging fruits that we're working on, and we aim to deploy it on our testnet in Q3 this year. And we, of course, hope that more projects jump on board, either on the relying party side, so people that want to use KILT identities, but also people that want to start providing their own identities to their own customers. Yeah, that's it. Thank you.